2024 A-Level Combined Mathematics Paper 1 Part B, question number 13, Part B. Part A of the same question was discussed in a previous video, link in the top right, and Part C of this question will be discussed in a future video, link in the top right. Part B of this question has to do with complex numbers. The question says, let Z1 and Z2 be elements of the complex numbers, and given this, we are asked to show that first, Z1 plus Z2 conjugate is equal to Z1 conjugate plus Z2 conjugate. We are then asked to show that Z1 times Z2 conjugate is equal to Z1 conjugate times Z2 conjugate, and finally we are asked to show that Z1 times Z1 conjugate is equal to the modulus of Z1 squared. And finally they say, using the result that Z1 divided by Z2 conjugate is equal to Z1 conjugate divided by Z2 conjugate for Z2 not equal to 0, show that if Z1's modulus is equal to 1, but Z1 is not equal to plus or minus 1, meaning that Z1 is not a real number, it is some other complex number that has a modulus of 1, and also if Z1 plus Z2 divided by 1 plus Z1 times Z2 is a real number, then the modulus of Z2 must be equal to 1. Now to start off this question, what we're going to do is to assume that Z1 and Z2 are elements of the complex numbers and try to prove each of these three identities separately by using Z1 is equal to A1 plus B1I and Z2 equal to A2 plus B2I for A1 B1 and A2 B2 element of the real numbers. So we're going to say for A1, A2, B1 and B2 element of the real numbers, we are going to let Z1 and Z2 be these values. So we're going to say let Z1 be A1 plus B1I and Z2 be A2 plus B2I for A1, A2, B1, B2 element of the real numbers. So now we have defined the complex numbers Z1 and Z2. Given this, if we go to the first question asks us to prove that Z1 plus Z2 conjugate is equal to Z1 conjugate plus Z2 conjugate. Now we can do this by considering both sides and trying to get from one side to the other. Starting off from the left hand side for equation number 1, we have Z1 plus Z2 added together first and then taken the modulus off. Or rather the conjugate off, not the modulus, the conjugate. Now considering this, Z1 is equal to A1 plus B1I, B1I, and Z2 is equal to A2 plus B2I. Therefore what we have is this expression and we take the conjugate of it. Now considering this expression, we can see we have real parts A1 and A2. When added together we get A1 plus A2 as the real part plus, and then here we have B1I and B2I, meaning that the imaginary part here is B1 plus B2 times I, and therefore the imaginary part is this, and we take the conjugate of this entire number. Now as we know, when you have a complex number, the conjugate is simply going to be the real part minus the imaginary part of the original number. Now according to that, the real part here is A1 plus A2, and therefore if you take the conjugate, it's still going to be A1 plus A2. However, the imaginary part is going to be subtracted instead of added. So therefore the imaginary part here is plus B1 plus B2 I. The imaginary part in the conjugate is going to be minus B1 plus B2 times I. Now according to this, we can see if we expand each of these brackets, we are going to get an A1 here, a minus B1I here. So we can write A1 minus B1I, and then we're going to get an A2, so plus A2, and we're also going to get minus B2I, so minus B2I. Now we can see here we have A1 minus B1I, A1 minus B1I here, plus A2 minus B2I. Now considering the first part, since Z1 is equal to A1 plus B1I, the conjugate of Z1 would be A1 minus B1I, which is exactly what we have in this bracket here. Therefore the first bracket simplifies to Z1 conjugate. And then we have plus, and the second expression here, A2 minus B2I, is simply what we get if we take the conjugate of Z2. Since Z2 is A2 plus B2I, Z2 conjugate would be A2 minus B2I, and therefore the second bracket here is Z2 conjugate, and we can see according to that, if this is Z2 conjugate and this is Z1 conjugate, we started with Z1 plus Z2 conjugate and ended up with Z1 conjugate plus Z2 conjugate, and therefore Z1 plus Z2 conjugate is equal to Z1 conjugate plus Z2 conjugate. Hence proven. Now we're going to do a similar thing for 2 and 3 as well. Considering 2, we have Z1 times Z2 first and then conjugated, and that's equal to Z1 conjugated times Z2 conjugated. Now according to that, if we go down, what we can do is to use the same Z1 and Z2 and consider Z1 times Z2 conjugate and substitute in Z1 equals A1 plus B1i and Z2 equals A2 plus B2i and simplify and see if we get Z1 conjugate times Z2 conjugate. Now according to that, what we're going to get here is A1 plus B1i times A2 plus B2i conjugate. Now considering this, if we simplify the internal bits, we're going to have A1, A2, and then we're also going to have B1i plus times plus B2i, which is going to be B1 times B2 and I times I. I times I is going to be I squared, which is negative 1, and therefore by definition B1i times B2i is going to become minus B1 B2. So we have minus B1 B2, and these two components here are the real part of the complex number that goes below this conjugation sign. Now considering the other part, we also have B1i times A2 and A1 times B2i, and both of these have I terms, and therefore they are in fact imaginary parts. Now considering the imaginary part, if I take the I out, we're going to be left with A1 times B2 and A2 times B1, which means we have A1 B2 plus A2 B1, and that is going to be the imaginary part, and both of these terms need to be conjugated as such. Now we can see once again we have a real part here and an imaginary part here, and when you conjugate a number, the real part remains as it is, so we still have A1 A2 minus B1 B2, but now for the imaginary part we have minus A1 B2 plus A2 B1 I. Now considering this, we can see if we again rearrange this back into the form where we have A1 A2 here, B1 B2 I over here, and then the internal complex parts, or rather imaginary parts, in the middle, we can see we're going to get A1 A2 minus A1 B2 I minus A2 B1 I, and then instead of writing minus B1 B2, I'm going to write plus B1 B2 I squared. Now considering this expression, we can see we can factor out an A1 from the first part, and similarly we can factor out a B1 from the second part and also an I. According to that, we are going to get A1 times A2 minus B2i, and if we factor out the B1 and I here, we are going to get a B1i, but if we instead making it a minus B1i, we can see B1i rather, we can see we're going to be left with an A2 here, and then if we factor out a minus B1i, we're going to be left with minus B2 and another I here, so we get A2 minus B2i. Now we can see both of these have A2 minus B2i, and when we factor that out, we have A1 minus B1i, and therefore what we have here is A1 minus B1i times A2 minus B2i. Now considering Z1 and Z2, Z1 is A1 plus B1i, so Z1 conjugate is going to be A1 minus B1i, and similarly Z2 is A2 plus B2i, and therefore Z2 conjugate is going to be A2 minus B2i, and according to that we can see the first term here is Z1 conjugate, and we multiply it by the second term here, which is Z2 conjugate, and therefore we can see we started with Z1 times Z2 conjugate, which means Z1 times Z2 conjugate is equal to Z1 conjugate times Z2 conjugate, and hence we have proven the second part of the question. Now for the third part, part 3, we are asked to show that Z1 times Z1 conjugate is equal to the modulus of Z1 squared. Now considering the first part, Z1 times Z1 conjugate, if we write it down as 3 here, Z1 times Z1 conjugate is going to be equal to A1 plus B1i times A1 minus b1i. Now considering this, we can see we have the difference of squares of a1 and a1 here, and plus b1i here, and minus b1i here. Therefore, this is going to be equal to the first term, which is a1 squared, minus the second term squared, which is going to be b1 squared, I squared. Now, I squared is equal to negative 1, and therefore negative I squared is equal to positive 1. And therefore, what we get here is a1 squared plus b1 squared. Now, we can see, since the modulus of z1 is simply equal to the square root of a1 squared plus b1 squared, since z1 is equal to a1 plus b1i, we can see according to this, modulus of z1 squared would be equal to a1 squared plus b1 squared, which is exactly what this term right here is. Now according to that, we can see, therefore, z1 times z1 conjugate must be equal to the modulus of z1 squared. And hence we have proven that part as well. So now we've proven the first three parts, and now we can move on to the last part where we have to use the result z1 divided by z2 conjugate equals modulus, or rather conjugate of z1 divided by conjugate of z2 for z2 not equal to 0, and that we have to use the result that if we have modulus of z1 equal to 1 but z1 not equal to plus or minus 1, and this term right here z1 plus z2 divided by 1 plus z1 z2 being real, we have to show that modulus of z2 is also equal to 1. Now in this kind of thing, if we are asked to prove some things and then we are asked to solve something, usually in the complex question, we are going to have to use the identities that we proved in the thing that we're solving at the very end. Now in this particular case, that is also the case. We need to use these three identities when we are solving this thing being real and z1's modulus being equal to 1, while z1 is not equal to plus or minus 1, in order to show that z2's modulus is also equal to 1. So going down, if we take a look at what we know that z1 plus z2 divided by the modulus of 1 plus z1 z2 is real. Now thinking for a moment, if we consider what real means, a real number is a number in the complex plane of the form z equals a plus bi, where b is equal to 0. That is what a real number is. Now considering that, if we consider z conjugate is going to be equal to a minus bi, but since b is equal to 0, this part is equal to 0, and therefore z is equal to a and z conjugate is also equal to a. Therefore, for a real number, z is equal to z conjugate. So according to this, if the expression that we're given here is real, then we must have that z1 plus z2 divided by 1 plus z1 z2 is equal to its own conjugate, z1 plus z2 divided by 1 plus z1 z2 conjugate. This must be the case if z1 plus z2 divided by 1 plus z1 z2 is a real number. Now working through this, we can see we have one number divided by another number conjugate. Now as we were told in the question, one number z1 divided by another number z2 conjugate is equal to z1 conjugate divided by z2 conjugate. Now we can see where this would be used. Now according to this, if we go down, we can see according to this, z1 plus z2 divided by 1 plus z1 z2 would be equal to the conjugate of this thing on the top, which is z1 plus z2 conjugate divided by the thing on the bottom's conjugate, which is 1 plus z1 z2 conjugate. Now here we can see once again we have the sum of two terms conjugated, and we have the sum of two terms conjugated, and we can also see if we distribute this conjugate inside, one conjugate is just 1, and then we have z1 times z2 conjugate, which is again the product of two numbers conjugated, which we've solved over here. z1 times z2 conjugate is z1 conjugate times z2 conjugate. Now therefore, if we simplify one more time, we can see we're going to get z1 plus z2 divided by 1 plus z1 z2 being equal to z1 conjugate plus z2 conjugate divided by, and if I expand the conjugate into this thing here, we're going to get 1 plus, and then Z1 Z2 conjugate, which is going to be Z1 conjugate times Z2 conjugate. And this is what we get when we apply the three rules that we had so far. Now, considering this expression, we can see if we want to make this into an equation that we could potentially use in order to get the modulus of Z2 as being equal to 1, as we were given in the question like this, we would probably want to get rid of the denominator. So therefore, let's try to get rid of the denominator by multiplying this side by 1 plus Z1 Z2 and multiplying this side by 1 plus Z1 conjugate Z2 conjugate. According to that, we're going to get Z1 plus Z2 multiplied by 1 plus Z1 conjugate Z2 conjugate being equal to, and on this side we're going to get Z1 conjugate plus Z2 conjugate multiplied by 1 plus Z1 Z2. Now this is what we get. Considering this, we can see if we expand the brackets, we're going to get Z1 plus Z2 plus Z1 times this, which is going to be Z1 times Z1 conjugate times Z2 conjugate, or rather I made a mistake, I typed that as Z2 conjugate, Z1 conjugate times Z2 conjugate, and then we're going to get Z2 times this, which is going to be written as plus Z1 conjugate times Z2 times Z2 conjugate. Now I'm purposefully writing Z1 and Z1 conjugate together and similarly writing Z2 and Z2 conjugate together because we can do another simplification based on the identity that any number Z times its conjugate is equal to its modulus squared. Now moving on for the right side, on the right side we can see we have this times 1, which is going to be Z1 conjugate plus Z2 conjugate plus Z1 conjugate times this thing, which I'm going to write as Z1 times Z1 conjugate times Z2, and then I'm going to move this stuff a little bit to the left to get a little bit extra space, and then we're going to have the other term, which is Z2 conjugate, this term times this, which is going to be plus Z1 times Z2 times Z2 conjugate. Now considering the terms that we have here, we can see we have Z1 and Z2 here, which I'm going to leave as is Z1 plus Z2, but then we have Z1 times Z1 conjugate times Z2 conjugate. Now Z1 times Z1 conjugate, as we found above, is equal to Z1 modulus squared. Now as we were told in the question, Z1 modulus is equal to 1, but Z1 is not equal to plus or minus 1. Now from this part we can see if Z1 modulus is equal to 1, then Z1 modulus squared must also be equal to 1. And therefore, this term right here, Z1 times Z1 conjugate, is going to be equal to 1, and therefore this term boils down to just Z2 conjugate. And then we have plus this term, which is going to be Z1 conjugate multiplied by Z2 times Z2 conjugate, which is the modulus of Z2 squared. And on the right side we can see we have Z1 conjugate plus Z2 conjugate plus, and then we have Z1 times Z1 conjugate, which is going to be equal to the modulus of Z1 squared, which is equal to 1 times Z2, which is just Z2, and then we have Z1 times Z2 times Z2 conjugate, which is going to be equal to Z1 times the modulus of Z2 squared. Now considering what we have here, we can see on the left side we have Z1, on the left side we have Z2, and on the left side we have Z2 conjugate. On the right side we have Z1 conjugate, we have Z2 conjugate, and we have Z2. Now according to this we can see we can cancel out this Z2 for this Z2 and this Z2 conjugate for this Z2 conjugate, and then we're going to be left with Z1 plus Z1 conjugate Z2 squared, Z2 modulus squared, and on this side Z1 conjugate Z1 times Z2 modulus squared. Now if we take everything to one side, we can see we have Z1, and then we have minus Z1 conjugate, and then we have plus Z1 conjugate times Z2 modulus squared, and then we have minus Z1 times Z2 modulus squared, and that's going to be equal to 0. Now here we can see if we try to factor Z1 minus Z2, we're going to get Z1 minus Z1 conjugate, we're going to get Z1 minus Z1 conjugate, and then we have 1 here since we have one of them, but then we have Z1 1 conjugate minus Z1 times Z2 modulus squared. Now if we factor out the Z1 minus Z1 conjugate here, we're going to get minus Z2 modulus squared. Of course, because in order to get Z1 minus Z1 conjugate, we need to apply a minus here to get minus Z1 conjugate for this term, and minus Z1, which can be plus Z1 for this term right here. And therefore, if we factor out the Z1 minus Z1 conjugate, we're going to be left with 1 minus Z2 modulus rather squared equal to 0. Now considering this, either Z1 minus Z1 conjugate is equal to 0, or this term right here is equal to 0. Now, in order to figure out which one of these two is equal to 0, we need to go up and consider what they told us about Z1. So for Z1, they told that the modulus of Z1 is equal to 1, but they also said Z1 is not equal to plus or minus 1. Now plus or minus 1 are the only real numbers for which the modulus of the real number is equal to 1. Now according to that, if Z1 equals plus and minus 1 is not the case, but Z1 is modulus equal to 1, then Z1 cannot be a real number. Considering all of the complex numbers in the circle here, if Z1 is not equal to this number or this number, then Z1 is definitely not a real number, it is a complex number. So we can apply that logic here and say, if modulus of Z1 equals 1, but Z1 not equal to plus or minus 1, from these two facts we can say Z1 is not an element of the real numbers. Now according to this we can say this means that Z1 is not equal to Z1 conjugate, because if it was equal, it would have to be a real number. So according to that, Z1 is not equal to Z1 conjugate, leading us to Z1 minus Z1 conjugate not being equal to 0. Now if that term is not equal to 0 and we have that term times this term being equal to 0, it must mean that this term is equal to 0, and therefore we can say that term, which is 1 minus Z2 modulus squared, must be equal to 0, leading us to Z2 modulus squared being equal to 1, since the only way this is equal to 0 is if this is equal to this, and therefore Z2 modulus squared is equal to 1, meaning that Z2 modulus is equal to 1. Now it cannot be equal to minus 1 because of course the modulus function only gives you a positive value, and therefore we can say Z2's modulus must be equal to 1 given all of the conditions that we were given so far. So here the only real special thing is using the fact that this number right here is real to say that it must be equal to its own conjugate. That's the only special thing that we've done here. Other than that, everything is quite simple. We've done some algebraic simplification using the facts that we know from the question in order to find our answer, and we also had to use the identities that we were asked to prove in the question. Now that of course is a common pattern. Sometimes, rarely, you might not be actually required to use the identities that you were asked to prove in the question. Sometimes you might be used to use identities that are outside of the things that you proved in the question. But for now, we can see everything that you used in the question, everything given in the question, and everything proven in the question is what you use to solve the final answer of the question. And that's going to be all for this question. So now finally, let's discuss the marks awarded for this question. So at the start of the question, for the first proof, when you substitute Z1 and Z2 as A1 plus B1i and A2 plus B2i, and you get to this point where you have a real part and imaginary part, A1 plus A2 and B1 plus B2i respectively, and you take the conjugate correctly, converting the imaginary part negative while keeping the real part as it is, you get 5 marks. And then when you rearrange the terms that you get into the form A1 minus B1i and A2 minus B2i, you get 5 marks for that. Now after this, for the second proof, when you again do the same exact thing, where you convert this into A1 plus B1i and A2 plus B2i, and then you make a real number part, an imaginary number part like this, and take the conjugate correctly. For taking the conjugate, you get 5 marks. Now after that, when you rearrange the conjugate into this form like this, we have A1, A2, B1, B2i squared here, and the other two terms in the middle, and you factorize. For arranging like this, you get 5 marks. And when you factorize that into A1 minus B1i and A2 minus B2i, that gets you another 5 marks. Now for the third proof, when you take Z1 times Z1 conjugate and you substitute in A1 and B1i and A1 and B1i like this, and you get A1 squared plus B1 squared like this, you get 5 marks. After that, when you say that since modulus of Z1 is the same exact thing, when you square it, we can see that both of them are the same. Writing out this part gets you another 5 marks. Now after that, when you then move on to the proof that they gave, where you have Z1 plus Z2 divided by 1 plus Z1 Z2 being real, when you say that this must mean that that number is equal to its own conjugate like this, saying that gets you 5 marks. After that, when you simplify it down using the 3 conjugate rules that we had in our question like this, for the 2 conjugate rules of addition and multiplication, you get 5 marks. Now after this, when you get to this point and you expand everything like this into one single line without any brackets, expanding it like that gets you another 5 marks. Now after this, when you use the third conjugation rule, Z1 times Z1 conjugate is equal modulus of Z1 squared, and you simplify down to this point where you have Z1 minus Z1 conjugate times 1 minus Z2 modulus squared equals 0 like this. Getting to this point gets you 5 marks. After that, when you use the argument that Z1's modulus is equal to 1, but Z1 is not equal to plus or minus 1, meaning that Z1 is not named as real numbers, and therefore Z1 minus Z1 conjugate is not equal to 0, leading us to 1 minus Z2 modulus squared equals 0, meaning that Z2 modulus squared equals 1, meaning that Z2 modulus equals 1. For all of this and the final answer Z2 modulus equals 1, you get another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.